Hello students, welcome to the lecture on graphics and user interfaces. And after the lecture we will be able to learn the following objectives. Understand the graphics contexts and graphic objects. Describe color control in Java. Explain the method for drawing strings. Understand the concept of interfaces. Discuss how to implement interfaces. Let's start with a brief introduction to graphics and user interfaces. Software that works at the point of contact, interface, between a computer and its user, and which employs graphic elements, dialog boxes, icons, menus, scroll bars, instead of text characters to let the user give commands to the computer or to manipulate what is on the screen. GUI elements are usually accessed through a pointing device such as a mouse, pen, or stylus. All programs running under a GUI use a consistent set of graphical elements so that once the user learns a particular interface, he or she can use all programs without learning additional or new commands.
What is going on, people? Welcome to your 50th Java tutorial. And I know it's been a while since I started making Java tutorials, but hey, we're going to get back on track and start learning some more Java. So actually I had planned out that we're going to learn polymorphism, but I think I'm just going to skip right to GUIs because it's a lot funner and it's better if we know how to make an interface before we start getting into some other stuff. Plus, when we have an interface and stuff, you can see what everything does, and you're not just typing random code that you're like, alright, what is this, the matrix? Because, you know, it's time we started building an application that the user can interact with and see. So if you don't know what a GUI is, or some people call it a GUI, it's a graphical user interface. And just like this right here, it has a title bar at the top, menu, drop downs, it has a whole different range of buttons. And that's what we're going to be making instead of this right here where it's like the matrix style, because, I mean, come on, it's 2009. If you're watching this tutorial in 2009, that is. So let's go ahead and get started. Now the first thing you need to know is that all GUIs are built from GUI or GUI components. That means there has to be a component for a menu, a dialog box, scroll bars. You have to add each one of those individually. So how do you just go ahead and get these components? Well, actually, Java has a built-in class that stores all the components you need. You just need to tell it where to put it and what to do with it. And they are created using different methods. And the methods you use to create this in the class is called the JOptionPane class. Now, like I said, this class is built into Java. So anytime you want to make a button, all you need to do is call it from the class. And there are different ways to do this, but this is the easiest way. So in order to get all those buttons and toolbars and everything, we first need to import the entire class. So let's go ahead and before your even class right here, just go ahead and put import javax dot swing dot j option pane, and make sure you type the J and the O capital option pane, and just like that. And now we're getting a little error that says the import Java JOptionPane is never used. So let's go ahead and fix that by using some stuff right now. So now we imported the class, which means we have access to all the crap in it. So let's start using some of that crap. The first thing we're going to want to do is set two variables. By the way, I'm going to build a program where you enter a number in one box and then click OK, you enter a number in another, click OK, and the end box, the third one, shows your answer. You'll see in a little bit. So we need to set this equal to a string variable and set it equal to first number, and I'm just going to write fn, or fn for first number. Now what you need to do is call the class, which is JOptionPane, use your period or dot separator, and the method for an input dialog is show input, if you couldn't tell by these 100 pop-up things that pop up, dialog. And it's going to take one parameter right here, and this is the message. Now what this is the message or the prompt which you want to tell the user to do. So we just want to put in a string, enter first number. So now whatever they enter into that first number is going to be stored in the variable fn. So now we need a second number, so let's go ahead and copy this, press enter, paste it, and let's just set string second number, and we'll just put enter second number right there. Make sure I got my whatever it's called, semicolon. And let's go ahead and move this over here because just because I feel like it. Now here's a little thing that you need to know. Every time they enter something in here, show input dialog method only is able to get a string. So we can't add strings. Strings are pretty much letters and numbers that it doesn't see as a number. So we need to tell Java, alright, instead of viewing this as a string, we want you to view it as an integer so you can do some math with it later on. So what we need to do is convert these variables to integers. So this has nothing to do with JOption pane. This is just Java right here. So Java int num1 equals integer dot parse int. And what this does is convert whatever I type into here and stores it as an integer in num1. So I want to put fn, and what this does is take the string, which say it's 5, and converts it into the number 5. So now let's go ahead and do this for num2. Num2, we want to take the second number we typed in and convert it to a variable called number2. So now the last thing we need to do is just show the sum. So before we even do that, let's just add the sum. Int sum equals what do we put? Num1 plus num2, no spaces. And now we got the final answer in the sum variable right here. Let's tighten that up a little bit. That's what she said. And now we can go ahead and display this. Now the box that you use to display is something called show message dialog. So let's put JOption pane dot show message dialog. And this is a little different than show input dialog. Inputs for inputting, messages just for displaying. Now this method takes 4 parameters. The first one is it's a parameter where to position it, and if you put null, it positions it right in the middle of the screen. The second one is what you want to say, like for your prompt, but it isn't prompt, it's just a message. So let's put the answer is, and let's just put add sum. So it's going to be like the answer is 5 or something like that. Now the third parameter is what you want to appear on your title bar. So let's put like the title or something easy like that. And the fourth parameter you need is the message that's going to pop up. Now I'll go over this later if I got time, but for right now just put JOption was it pane, then put plain underscore message like that. And you don't need to put this last thing in quotation marks. So again, well, that's pretty much it. Let's just go ahead and run this program. I'm tired of waiting around. So let's go ahead, click OK, run it. Enter your first number, 3. Okay. Enter your second number, 5. Okay. The answer is 8. And now I can talk you.
Let's now take a look on graphics contexts and graphics objects. Graphic context in desktop, Java usually means java.awt.graphics or java.awt.graphics2D classes. They carry information about drawing properties, colors, line properties, clipping regions, etc. A graphics object manages a graphics context and draws pixels on the screen that represents text and other graphical objects. Example, lines, ellipses, rectangles, and other polygons. Graphics objects contain methods for drawing, font manipulation, color manipulation, and the like. Class graphics is an abstract class. Example, graphics objects cannot be instantiated. This contributes to Java's portability. Because drawing is performed differently on every platform that supports Java, there cannot be any one implementation of the drawing capabilities across all systems. Let's now have a look on color control. Class color declares methods and constants for manipulating colors in a Java program. The predeceased color constants are shown here. Every color is created from a red, a green, and a blue component. Together, these components are called RGB values. All 3 RGB components can be integers in the range from 0 to 255, or all three can be floating point values in the range 0.0 to 1.0. The first RGB component specifies the amount of red, the second the amount of green, and the third the amount of blue. The larger the RGB value, the greater the amount of that particular color. The INT values must be in the range 0 to 255, and the float values in the range 0.0 to 1.0. The new color object will have the specified amounts of red, green, and blue. Color methods getRed, getGreen, and getBlue return integer values from 0 to 255, representing the amounts of red, green, and blue respectively. Let's know how to draw strings. Draw the specified text string at the specified location with the specified brush and font objects. This member is overloaded. When the application brings execution, class color JPanel's paint component method is called to paint the window. It uses graphics method setColor to set the drawing color. Method setColor receives a color object. The expression newColor 255.0.0 creates a new color object that represents red value 255 and 0 for the green and blue values. The first two integer values represent the upper left x-coordinate and upper left y-coordinate, where the graphics object begins drawing the rectangle. The third and fourth arguments are non-negative integers that represent the width and the height of the rectangle in pixels, respectively. Here you can see the syntax for drawing string. Let's now have a look on the graphics methods. Draw on a JComponent or JPanel by overriding paint component method. Assume G is a graphics object and all variables are type int unless otherwise declared. Angles. int start angle, arc angle are in degrees counterclockwise from 3 o'clock. These methods use xy at the top, left corner, and a width and height of the bounding box, except drawString method and drawLine method. Here we will discuss about interfaces. Declaring interfaces. An interface declaration consists of modifiers: the keyword interface, the interface name, a command-separated list of parent interfaces, if any, and the interface body. Let's understand better with an example. The public access specifier indicates that the interface can be used by any class in any package. If one does not specify that the interface is public, then the interface is accessible only to classes defined in the same package as the interface. Extending interfaces. An interface can extend another interface, similarly to the way that a class can extend to another class. The extends keyword is used to extend an interface, and the child interface inherits the methods of the parent interface. Let's see an example of hockey and football interfaces. The hockey interface has 4 methods, but it inherits 2 from sports. Thus, a class that implements hockey needs to implement all 6 methods. Similarly, a class that implements football needs to define the 3 methods from football and 2 methods from sports.
Hi, this video is from interview.com. Interview.com is a job portal. If you're looking for a job, you can log on to interview.com and you can post your resume with us. In this video, I'm going to talk about very important Java integration. What is an interface in Java? All interface methods are implicitly public and abstract. You do not need to actually type the public or abstract modifiers in the method declaration, but the method is still always be public and abstract. Interface means it will have method signatures like method name, method input, and the return type that is going to return. The implementation should be given by the class that is going to implement the interface. So interface will only contain the what portion, or I will say contracts. How portion will be given by the class that is going to implement the interface. I'll be showing the code for more understanding. All variables defined in an interface must be public, static, and final. Interfaces can declare only constants. You should not have instance variables. Please remember, interface methods must not be static, because whenever you say static, it applies to the class level, but interface concepts are applied to the object level, where you can have polymorphism and other stuff. Interfaces cannot be marked as final, strict FP, native. You know what is native. What is final means? Final means you can't allow any class to extend, but interface should be implemented by any other class, because there is no use if some class does not implement it. An interface can extend one or more other interfaces. Please remember, It can extend one or more other interfaces. An interface cannot extend anything but another interface. An interface cannot implement another interface or a class. It can only extend from another interface, but it cannot give any implementation. An interface must be declared with the keyword interface. Let's see the code so that you can understand. So I have an interface here. Interface, you should use the word keyword interface account. I have a method signature. Can you see here? I can have abstract modifier. If I don't have, also there is no problem. The compiler will not give you any error. So I have an interface, and this interface is implemented by debit account. That means this has a method signature contract information. So this should give the code, that is body for that method. If I don't give the body, you will be getting a compile error. It will say must implement the methods which is inside this one. So the moment I say add unimplemented methods, it will add the methods. Okay, so this is how interface works in Java. Hope this video is useful for your Java interview preparation. Thank you and all the best.
Let's now know how to implement an interface. To declare a class that implements an interface, one includes an implements clause in the class declaration. One class can implement more than one interface, so the implements keyword is followed by a comma-separated list of the interfaces implemented by the class. By convention, the implements clause follows the extends clause, if there is one. A sample interface, relatable. Consider an interface that defines how to compare the size of objects. An example is shown here. Any class can implement relatable if there is some way to compare the relative size of objects instantiated from the class. For strings, it could be number of characters. For books, it could be number of pages. For students, it could be weight, and so forth. For planar geometric objects, area would be a good choice, while volume would work for three-dimensional geometric objects. All such classes can implement the isLargerThan method. Implementing the relatable interface. Let us understand how to write the rectangle class rewritten to implement relatable. Because rectangle plus implements relatable, the size of any two rectangle plus objects can be compared. Let's now take a look on interface and abstract classes. Interface. An interface is a type which contains only the signatures of methods, delegates, or events. It has no implementation, and implementation of the methods is done by the class that which implements the interface. Interface is a contract that defines the signature of the functionality. So if a class is implementing an interface, it says to the outer world that it provides specific behavior. Abstract classes. An abstract class is a class that contains complete and abstract incomplete, both type of member, and it cannot be instantiated. Abstract classes are one of the essential behaviors provided by .NET. Interface contains only definition, signature of functionality, and if one has some common functionality as well as common signature, then there is a need of abstract class. So through abstract class, one can provide behavior as well as functionality, both in the same time. Developer inheriting abstract class can use this functionality and need to fill only in the blank.
Welcome to this video on abstract classes and interfaces. My name's Andy Wicks. Before I get going, let me explain that abstract classes are not the same as abstraction in object-oriented programming. They're two completely separate concepts that, well, are there primarily, of course, to confuse people. In this video, we're going to look at how to make your life a little more logical as a programmer. And the more logic there is in what you do, the easier it is to program, and obviously the easier it is to debug too. Let's suppose that I want to create a class that gives the user the time, day, date, and so on. I'm going to call this class myTime. And I want to ensure that when the user uses this class, they create a method called display. Display will output the result. But how the user displays it, well, that will be different for each particular program. So I don't want to put the code in here I want the user to be able to say which code they want in there, but I want to be sure that they do have a display method. Now you've seen this before when you've extended JFrame and you're forced to have an action performed method. The action performed method is created in exactly the same way as we're creating this here. What we're going to have is something called an abstract class. And an abstract class has methods declared in it that don't have any code, but they're declared as abstract. And that means that the user must implement them when they create their program. So I'm going to have public abstract void display, and I'm going to ensure that the user has a display method in their program. I can also create other methods that are coded. So for example, public static string getTime. GetTime returns the time in a particular format. And public static string getDate returns the date with the day of the week as well. So that is fairly standard Java. Let's have a look at how it's implemented. For that, we're going to go and create a little digital clock. Here in the digital clock program, I'm going to create the program, public class digital clock, and I'm going to extend my time. In other words, I'm going to inherit all the methods and all the variables from my time. Now my time doesn't have any variables, so that's okay. I can leave that as it is. But it extends my time, and because my time has the abstract class in it, you'll notice that down here I have @override, which means that we're creating another instance of, and then void display is the method that I'm forced to implement by the abstract class. Now in my case, what I'd like to do is to create a variable called time, which includes the date and time for now. And it does this every second. That's what the bit above does with the timer and so on. That we're not interested in this video. What we're interested in here is that the public void display must be there because it was in our mytime.java. So let me show you this running. Now it's fired and fired again and so on. You can see that every second it's printed out the time and date. Not a difficult program. An interface is something similar. Let me show you an interface, a really complicated one. Okay, I'm lying to you as usual. You can usually tell when teachers are lying, their lips move. In an interface, what we do is create the same sort of abstract methods as we did in the abstract class, but in this case, there are no methods, no variables that are implemented. It just consists of abstract methods. Abstract methods must be instantiated, as we said before. So let me go back to my digital clock program and show you what happens when I use this interface. It's called new interface because, hey, it's new. We can have on the end here implements new interface. And you'll notice that in NetBeans, digital clock 1 is now underlined in red. It looks as if we've made a mistake, but we haven't. What we have to do is to implement all abstract methods. In other words, those two methods that were there in new interface, first and second. When I click on this, I now get the two new methods appearing at the bottom. Here are the two new methods. first and second. First was just a method, and in there we would do whatever it is we want it to do. At the moment, obviously, it's not coded, so it's throwing an unsupported operation exception, but that's fine. We can just override that with comments if we don't want to program it yet. And the second one, well, that's a function, returns a string and takes in an integer, which it's going to call x. You've seen that sort of thing with the action performed method that you have to have if you create a graphical user interface.
Now in the end, let us summarize what we have learned in this lecture. GUI elements are usually accessed through a pointing device, such as a mouse, pen, or stylus. All programs running under a GUI use a consistent set of graphical elements, so that once the user learns a practical interface, he or she can use all programs without learning additional or new commands. Context is a generic name that many Java developers use for classes that carry state information. So we are bound to see a lot of different class names containing context. Class graphics is an abstract class. Example, graphics objects cannot be instantiated. This contributes to Java's portability. Because drawing is performed differently on every platform that supports Java, there cannot be only one implementation of the drawing capabilities across all systems. An interface declaration consists of modifiers, the keyword interface, the interface name, a command-separated list of parent interfaces, if any, and the interface body. A Java class can only extend one parent class. Multiple inheritances are not allowed. Interfaces are not classes, however, and an interface can extend more than one parent interface.